Hi everyone, let's solve today's daily challenge, that is implement queue using stacks. Now this question might be seeming simple, but from an interview point of view, this question is a very important question because it helps the interviewer to understand whether or not you are comfortable with the fundamentals, right? So fundamentals are the basic building blocks, and for that reason you must be very well versed with such problems. Now let's get into the question. So here what we have to do, we have to implement a queue using two stacks, right? So here we can see this is first in first out queue, and we have to use two stacks only, and the implemented queue should support all the functions of a normal queue, right? So basically what we have to do is we have to implement the functions of a queue, right? So let's first see what a queue is. So queue is nothing but a linear data structure, right? Looks just like array, but what's special about a queue? A queue data structure follows something called FIFO, or first in first out order, right? So this is similar to a real case scenario. Let's say we are going to buy movie tickets, right? So there is a line, correct? So in that line you have to stand and wait to get your movie ticket, right? So let's say this is your line, and whoever is in the front gets the movie ticket first, right? So whoever comes first gets the movie ticket first and gets removed from the queue. So similarly we have this queue data structure, right? So what are the different functions of this queue data structure? We have push, we have peek, we have pop, and we have empty. Okay, so what does this push function means? So push basically means we want to add a new element to the queue. So let's say there are some elements, right? So we know this is first in first out order, right? So let's say let's create an analogy with the movie ticket scenario, right? So let's say there is already this line, right, and I have to get a movie ticket. So where will I stand? After the last person I have to stand here. So similarly in a queue, after the last element we have to add an element to the queue. So push means nothing but add an element, and where do we add it? After the last element of that queue. Then is peek function, right? So peek basically means, let's say whoever is giving the movie ticket asks who is standing in front of the queue, right? So we will peek and say, okay, this person, let's say A person, is standing here. So peek means nothing but to check what is the front element of the queue. Then what is pop? So because a queue follows FIFO order, that is first in first out, so whoever comes first inside of the queue gets removed first. So pop basically means we are popping an element, and in a queue the element is popped from the front of the queue. So whatever element we peeked, so this person A was standing here, so when I call this pop function, that means I have to remove this person. So this person gets removed. So what do we remove? We remove the front element of the queue, right? Then is empty. So this is a function basically to check whether or not this queue is empty. Okay, so now we have understood what are the different functions present in a queue and what basically a queue is. Now let us understand how are we going to use stack to implement this queue data structure, right? So we are not given the liberty to use an array or string or anything, but we are told that we only have this stack data structure, and using that data structure we have to implement this queue. Now quickly I'll tell you what the stack data structure is. So stack data structure is nothing but it is also a linear data structure which follows what? LIFO order. So whatever element goes first inside of this stack will be the last element of this stack, and whatever element goes last in the stack will be removed first, right? So this is similar to books being stacked, right? Let's say these are the books, so whichever book you put on the top of the stack, that you can remove first, right? So the last book gets removed first. So that is what a stack data structure is. Now in stack data structure again we have functions called push, pop, right? And in stack this peek function is called top function. Okay, so top function basically returns you what is at the top of the stack, right? Let's say I have some books here, and I have to tell what is the top element of this book stack. So let's say this is book C, right? So this is the top element. So in stack, we already always return the last element that goes inside the stack. Okay, so push basically means putting an element inside the stack. So everything happens only on one end, right? Here we were removing from first end and we were inserting at the last end. But here, whatever we insert at this end gets removed from this end only. So that is the stack data structure. Also, the peak function is called top function in case of stack, because we are returning what is present at the top of the stack. Now we are clear what stack data structure is, etc. We have to use this data structure to implement a queue. Now, how are we going to do this, right? So for solving this problem, we will be taking two stacks. Okay, so let me first clear the screen. So as we said, we are going to use two stacks to solve this question. Okay. Now let's say I want to add this two element, right? So let's say this is my stack 1, this is my stack 2, right? So what I will be doing is whatever I have to insert, right, that I will be doing in stack 1. So in stack 1, I will put this element. Now let's say I put these two elements again inside the stack. So first 1 goes, then 3 goes. Now, if let's say if these elements were present inside of Q, this would have been the scenario. Now let's say I want to pop the element from the Q, right? So what element gets popped? The front element. Now in this stack, we can see it is present at the bottom, but in stack, we can only remove the top element of the stack, right? So if we only use this stack 1, then we will not be able to implement something like this. So what we will do is, that is the reason we take two stacks. We will empty out this stack 1, and first we will take the last element of this stack and we will push it inside of this stack 2, right? Then we will, so 3 is not here, then we will take 1, push it in stack 2, and then we will take 2 and push it inside of stack 2. Now we can see that we have gotten an order like 2 1 3, and if I want to pop an element now, what I have to simply do is I have to remove the top element of stack 2. Now 2 is removed, right? So 2 is removed from the queue. So this is just how things are going, but this is basically what we are using. Now when 2 has been removed, we have to put this 1 and 3 again in stack 1, because we have to implement all the insertion inside of stack 1. So let's say stack 1 is right now empty, and I, let's say, push this 4 element here, right? So it should have been like this, right? And now let's say I go again and try to pop an element. So the popped element should be 1, but in this case, because I will follow the same logic, that is I will remove this 4 and put this inside of stack 2. So now if you see, I'm getting 4 as the popped element, which is wrong, right? So we have to get 1. So that is the reason why we will only do insertion stack 1, but after we have popped an element from stack 2, we have to put all the elements back in stack 1. So here is stack 1, right? So let's say 4 is not here. So first we will put these two elements in stack 1, right? After this popping operation of 2. So we'll put 1 and 3. Now let's say I want to insert 4. So I'll insert 4. Okay, now let's say we go here and let's say I say remove the top element again, right? Pop the top. So then again inside of stack 2, right? So here will be 4, here 1, here 3 will be there, and here 1 will be there. Now you can see if I remove the top element from this, then 1 gets removed, and that is what I need to get, right? So I hope you're understanding what we are basically doing. Whatever insertion I have to do, I will do it inside of stack 1. But whenever I will be popping these elements, I will be using the stack 2, right? So after I have used this stack 2, I will remove this element and I will move back the remaining element inside of stack 1 again to preserve the order of a queue, right? So I hope you understand this. So we will put these again here, right? Because 4 have been, okay, 1 have been removed, right? So 4 is present here, 1 have been removed. So we will put 3 and 4 inside of this stack. So 3 is here, 4 is here. So basically now we can see the order of a queue data structure has been preserved using two stacks. Now similarly, this pop operation, what we are doing is we are using stack 2 when we have to pop. So let's say whenever we have to print the top element, then also we have to do the same thing. That is, from stack 1, put everything in stack 2 and return the top element. But the difference is only that we will not be removing anything from stack 2, and again, after accessing what is the top element of stack 2, we will put all the elements back in stack 1, so that order is maintained throughout, right? So now let us go ahead and try to implement it. So let us write the code here. So here we can see we are given these functionalities, right? We are given push, pop, peek, and empty. So we have to basically write the code for them. So first thing we have to do is declare these two stacks. So we'll declare stack 1 and stack 2. Now, because we are not initializing anything here, we will skip writing this myQ constructor. Now we will go straight to the push operation. Now in push operation, as I said, everything has to be inserted in stack 1. So we don't have to, do a lot of logic building for pushing. So we will simply say, put the element inside of this stack. So what element are we pushing? We will be given through this function, that is x element, that we will push inside of stack 1. Then when we have to pop an element, we have to use the stack 2. Now first thing what we have to do is we have to put all the elements of stack 1 inside of stack 2, right? So I will write a while function here to empty out this stack, right? So we will be iterating in this while function until this stack 1 is empty, right? So first I will access the top element of this stack 1, right? Because in stacks we always play with the top element and we can only pop them. So then I will remove this element from the stack 1. Now what I have to do, I have to put this element inside the stack 2. So I'll say st2.push the top element of stack 1, right? After this we would have gotten our stack 2, right? Stack 1 will be empty. So what do we have to pop? We have to pop the top element of this stack, because that element will be the front element of the queue, and from queue we remove the front element. So we will say, so we will put this popped element here, because we have to do one more thing, that is, after we pop an element from stack 2, we have to put every element inside the stack 1, right? So we will take the top element of stack 2. Now we will pop this element from stack 2, right? And then put the remaining element back in stack 1. So I will have similar loop, right? Let me just copy it from here. Okay, so here we have to empty the stack 2 and we have to put all these elements in stack 1, right? So stack 2 this will be, and this will be stack 1. Now after we have preserve the order, we can simply return what element we have popped, because we have to return an element here. So we'll return this popped element. All right, now is the second function, that is peek. So peek is very similar to pop. It's just that we do not have to pop anything from stack 2, right? Because we are just seeing what is present at the front of the queue. So we can simply copy this and paste it here, and we can remove this line, right? And this will be my front element of the queue, right? And here we can simply return this front element. So just like in pop operation, after we pop, we have to in order to preserve the order of the elements, right? So we have to put everything inside of stack 1 from stack 2, right? So that is what we have to do here as well. So that is it. So peek function is complete, push function is complete. Now in what do we have to do in empty function? So as I said, in stack 1, right, we basically have the queue. It is only to pop and peek we go and put elements inside of stack 2. Otherwise stack 1 we can say is contains all the elements present inside of the queue. So if, right, I have to simply return whether or not my queue is empty. So if I just check if my stack 1 is empty or not, I can say whether the queue is empty or not, right? So here we can simply return st.empty. So now this empty function from stack 1 basically returns true if the stack 1 is empty and false if the stack 1 is not empty. So this empty function is for the same case, that is to tell whether the queue is empty or not. So that is it. Let's try to run this. Okay, so it is accepted, right? So that is basically how we have to solve this question.